In auto mode operation, the pressurization system is controlled automatically by the cabin pressure controller. The ambient altitude is sensed directly from the auxiliary static system. The barometric corrections to the pressures come from the captain's altimeter. On the ground, the controller continuously monitors the cabin altitude. Prior to takeoff, position the flight ground switch to flight, allowing the controller to pressurize the cabin slightly. Now touch the flight ground switch. Slight pressurization prior to takeoff reduces pressure surges and decreases noise inside the cabin. During climb and descent, the pressurization controller maintains a proportional pressure differential between the ambient and cabin altitudes. The pressure differential is maintained by keeping the cabin rate constant. The cabin rate, measured in feet per minute, is the rate of speed by which the cabin altitude climbs or descends. The cabin rate will not exceed 500 feet per minute during climb and 350 feet per minute during descent. In the example shown, the airplane will climb to a cruise altitude of 29,000 feet. The cabin will climb to a cruise altitude of 5,000 feet, and the differential pressure at the cruise altitudes will be 7.8 psi. The airplane rate of climb will be variable depending on thrust and ATC constraints, but the controller will maintain the cabin rate of climb at a constant 500 feet per. The differential pressure will rise gradually from 0.125 psi to 7.8 psi. At position A, the airplane rate of climb has increased to 2,000 feet per minute. The cabin rate has increased to its limit of 500 feet, and the differential pressure has gradually risen to 3.5 psi. At position B, the airplane rate of climb has further increased to 3,000 feet per minute. The cabin rate is still maintaining a constant rate of 500 feet, and the differential pressure has increased gradually to 5.5 psi. At position C, the airplane rate of climb has decreased to 1,000 feet per minute as the airplane approaches cruise altitude. The cabin rate has decreased to 0 because the selected cabin cruise altitude of 5,000 feet has been achieved, and the differential pressure is now 7.4 psi and still increasing. At position D, the airplane rate of climb is 0 because the selected cruise altitude has been achieved. The differential pressure is now 7.8 psi and stable. During cruise, the controller maintains a constant cabin altitude. If the flight altitude is less than or equal to 28,000 feet, the controller maintains a 7.45 psi differential. If the flight altitude is higher than 28,000 feet, the controller maintains a 7.8 psi. If the destination landing elevation, minus 200 feet, is higher than the cabin cruise altitude at differential 7.45 or 7.8 psi, the controller maintains a lower differential pressure at cruise, which is based on the destination landing elevation, minus 200 feet. In the example shown, the planned cruise altitude of a flight from Omaha to Denver is 21,000 feet. At 21,000 feet, the cabin cruise altitude at a differential pressure of 7.45 psi is considerably lower than the destination. To minimize the differential pressure, the controller schedules the cabin cruise altitude to 200 feet below the destination elevation. During descent, the controller programs the cabin to land slightly pressurized. After landing, the first officer positions the flight ground switch to ground, allowing the controller to drive the main outflow valve slowly to full open. Now touch the flight ground switch to position it to ground.